Hey, what's up, my chem peeps? What in the heck are we gonna do in this vid? We're going to describe the properties of alloys. As always, breaking it down. 1. Define the term alloy. 2. Compare and contrast interstitial and substitutional alloys. Now, to start this vid, I like to think about my favorite book of all time, Lord of the Rings. Alright, so first, what the heck is an alloy? Alloys are blends of two or more elements, at least one of them being a metal, that are made by mixing together the elements in the molten state. The mixture is then cooled to produce a solid with metallic properties. Ooh, the molten state. Obviously, we couldn't just slam together the solid state of two different metals because we couldn't get them to mix. So we melt them down and then mix them together. We alloy them, and it's pretty amazing stuff. Now, for this class, you're going to have to understand some properties of alloys in terms of the size of the component atoms that make up that alloy. So the first type of alloy that you want to be comfortable with is substitutional alloys. These types of alloys form between atoms of comparable size. The radii of those different atoms are approximately the same. Here, one atom just substitutes for the other in the lattice. And that's possible because they're about the same size. Take a look at this thriller of an image that's on your screen and in your notes to illustrate a substitutional alloy. Notice that we've got our different elements there, copper and zinc, and their sizes are approximately the same. Therefore, when we get them in their molten state and mix them together to create the alloy, atoms of one can just sub in to replace atoms of the other. Second type of alloy that you want to be comfortable with is interstitial alloys. This type of alloy forms between atoms with different radii, where the smaller atoms fill in the interstitial spaces between the larger atoms. Steel is a great example of an interstitial alloy. Carbon occupies the interstitial spaces between the iron atoms. So again, you've got another thriller of an image on your screen and in your notes, this one describing an interstitial alloy, and notice how it compares to the substitutional alloy. The sizes of the atoms are much different. The carbon finds that interstitial space between the iron atoms. Now, note that in interstitial alloys, those interstitial atoms make the lattice more rigid, decreasing malleability and ductility. And this leads to some important, often improved properties depending on the type of application that we're trying to use with our alloy. Now, unfortunately, there's no system of nomenclature for alloys. We have an ionic system of nomenclature for ionic compounds, we've got a covalent system of nomenclature for covalent compounds, but alloys, you simply have to look them up or memorize them. We're talking things like brass, steel, bronze, pewter. No real set system of nomenclature here, things you just have to memorize. Don't worry, I'm not going to make you memorize any for the class. Couple last things to think about as we finish up this video on alloys. Recognize that the properties of an alloy typically lie between those of the component metals. Generally, the alloy remains malleable and ductile. And alloys typically retain a sea of mobile electrons and so remain conducting. Remember from metallic bonding that we've got this sort of sea of mobile electrons. The alloys, again, generally maintain this electron sea model of bonding. And then lastly, recognize that in some cases, alloy formation alters the chemistry of the surface. A great example of this is with stainless steel. A chemically inert oxide layer, I think it's a chromium oxide layer, forms on the surface of the stainless steel, which makes it more difficult to stain. And it's just one last thing I want you to keep in mind as you think about alloys. Makes me wonder what kind of alloy Sauron the Great used to create the One Ring. Alright, that does it for this vid. Have a fantastic day, my precious.